Good evening to one and all. Myself Tejas Sonje from Team Abhedya Racers welcome you all to the second day of Basics of Building a Formula Style Vehicle, and also a warm welcome to all our new viewers who have joined us today.
Thank you, Tejas. So let's begin with the session. We'll start with the 2.0 journey. this was our second year vehicle, the second beast manufactured by Team Abhedya Racers. Now let's move on to design session.
Hello everyone. We just saw the journey of TAR 2.0. Now let us see how these vehicles are designed and manufactured. In this session, we'll see the designing process. So basically, what is designing? It is nothing but initial process which is carried out before manufacturing. In simple words, it includes some common steps which are taken before manufacturing any product. These steps are identifying the problem, finding the answer, working on the idea, noting it down or drawing it, making a prototype, testing it, and from the results of testing, making the final product. Now, as we see, design is a systematic series of steps that helps in defining, planning, and producing a product. So, without further ado, I would like to explain you the basic designing process of our vehicle or any other vehicle. Let us begin. While designing a vehicle, we have to consider a few factors, such as why we are creating this vehicle. We have to get the maximum output from it. It should satisfy all the rules, aesthetics, and the most important of them all is driver's safety. Now, on your screen, you can see a vehicle. To design a vehicle, we need some subsystems. Those are steering, transmission, suspension, brakes, and roll cage or chassis. These subsystems play a vital role in designing a vehicle. Let us now see how to design each and every subsystem in more details. Moving on to the steering system first. On the screen, you can see the example of a steering system. This system is nothing but a group of linkages that transmit the movement of steering wheel to the front. The main purpose of a steering system is to allow the driver to control the direction of the vehicle while traveling. Now let's come to the designing part of it. These days, the vehicles which we see on the road use power steering. But according to the rules of the event, use of power steering is not allowed to transmit the motion from steering wheel to tie rods. So we have to use mechanical steering system. There are three different types of mechanical steering. Those are Davis steering or sliding mechanism, Ackermann steering mechanism, and anti-Ackermann steering mechanism. In Davis steering, the turning is done by using sliding pair. In Ackermann steering, the sliding pair of Davis steering are replaced by turning pair. This reduces the friction and also reduces the steering efforts. Anti-Ackermann is similar to Ackermann, but the only difference is that in Ackermann, while turning, the inner wheel has a greater angle than the outer wheel, and in anti-Ackermann, the outer wheel has greater angle than the inner wheel while turning. By comparing all three steering mechanisms, we come to a conclusion that Davis or anti-Ackermann steering systems would be difficult to steer at low or medium speed. So we selected the Ackermann steering mechanism. This helps to reduce weight of the steering column and provide good directional stability. After selecting that, you have to consider some factors such as caster, camber, toe in, toe out, scrub radius, kingpin inclination, etc. Now on your screen, you can see the various components of the steering system. To design a proper steering mechanism, first consider the weight distribution, then with the help of that we can check how much weight is obtained on each wheel. This will help you to find the normal force which is acting on the tie rods in static condition. When you find the normal force, you can Also find the amount of force required to move the wheels by using the formula F is equals to mu into Nm. Mu is coefficient of friction and Nf is normal force. With this force, you can find the movement which is generated at the pinion. With this movement which is required to turn the steering wheel, that is M is equals to F into steering wheel radius. For this you have to know the radius of the steering wheel. This is how we can design a steering system. After seeing the steering mechanism, let's move on to the suspension mechanism and how it is designed. The main focus while designing the suspension system should be to keep it as simple as possible and reliable to reduce the unsprung mass and CG height. On the screen, you can see the suspension of our vehicle, both the rear and front suspension system, pull rod and push rod geometry. Now, for designing a suspension system of a vehicle, first we have to start with the calculation of the CG height. Because every point and parameter of a vehicle is related to the CG height. To do so, get the idea or reference of the previous year vehicle CG height by keeping the ground clearance as minimum as possible. Adjust the CG height. After that, consider the weight distribution on both sides, that is the front and the rear side. By keeping the weight distribution equal, we can achieve a neutral steer condition. With the help of weight distribution, we can find the load on each wheel. This will eventually help you to find the ride rate and roll rate. Then come to the motion ratio, which we get in Lotus and can be validated in CATIA also. So what is motion ratio? It is the square of ratio of spring displacement to wheel displacement. Try to keep the motion ratio as close to 1 as possible to achieve better ride and comfort. Now we have motion ratio and ride rate. From that we can find the spring stiffness, which we can find by using the formula motion ratio into ride rate is equals to spring stiffness. When we find the spring stiffness which we need for our spring, we can manufacture it. The spring which we used in our vehicle is compression helical spring. The selection of the damper for the spring is done according to the geometry of the system. That is, there should be no restrictions caused by any other part of the vehicle when the damper is placed. While designing the suspension system, we have to consider three forces. Those are bump force, cornering force and braking force on the tire. According to these forces, the arms of the suspension are designed. While designing them, we have to keep in mind the factors of bending, shear and buckling. In our vehicle, we have used the push rod geometry at the rear, cause we were able to achieve the results which we wanted, and due to some space constraint as caused by the transmission system. The rear suspension system is coming on the screen. These are the various parts of the suspension system. Please have a look. After the rear suspension system, let's move on to the front suspension system. At the front suspension, we used pull rod geometry. The reason was that with pull rod, we get more downforce in the front of the vehicle with the help. This helps us to balance the weight distribution of our vehicle, cause as the engine is situated at the back, the weight at the rear section is more. So this geometry helps us to get more force at the front. And plus the geometry is between the suspension arms, so there is less drag created. The front suspension system is shown on your screen. There are the parts of the suspension system. As every system is interdependent, if any of the suspension parameters are changed, the steering also is affected, cause steering and suspension share the same factors. Those are camber caster, toe, KPI, scrub radius, etc. After seeing the steering and suspension system, now let's move on to the next one, which is brakes. Brakes are the safe components of a vehicle. The primary function of a brake is to stop the vehicle or slow it down in a certain amount of time. The efficiency of brake depends on the various factors such as the friction coefficient between the tire and ground, height of CG, frictional coefficient between disc and caliper, the unsprung mass. In our brake system, the master cylinder and brake caliper are OEM parts. We designed our brake system around them. To design the brake system, first we need to find at which pressure the wheels will lock. For that, we have to find the pressure generated in the master cylinder. Cause according to Pascal's law, the pressure change at any point in an incompressible fluid is transmitted throughout the fluid such that the same change occurs everywhere in the system. So this can be done by using the formula P is equals to F by A. That is the force acting on the master cylinder and area of the bore diameter. So to find the force on the master cylinder, we have to first calculate the force which the driver creates on the brake pedal. Which is multiplied by sending forward with the help of a pedal ratio. To get the idea of how this works, first the driver pushes the pedal, creating force on it, which gets transferred to the master cylinder and hence to the caliper piston. Here, pedal ratio is the mechanical advantage given to the pedal, which multiplies the pedal force given by the driver. So while designing the pedal such as brake pedal, we have to consider the pedal ratio, and to design the acceleration and clutch pedal, we have to consider the actuation angle at which they will actuate. Right now on your screen you can see the different components of the braking system. Now in our vehicle we have used a fixed type caliper. In a fixed type caliper, the force is distributed evenly on both sides. After that, the disc which we have used is manufactured and designed by us. To do so, we first find the braking torque by the formula braking torque is equals to braking force into radius of tire, and from that we can calculate the radius of disc by the formula radius of disc is equals to braking torque upon force on the disc. The material and thickness of the disc depends on the heat dissipation and the caliper. This is how we design the braking system. Now let us move on to the next system, that is transmission system, one of the important systems that is in a formula vehicle. The transmission department works around the principle of weight reduction, performance improvement, and gaining maximum speed and torque output. While designing the transmission system, we divide it into three parts, that is drivetrain, inlet system and cooling. Now moving on to the drivetrain. Drivetrain is defined as the system that transmits power from the engine to the wheels with the help of the components such as engine, pinion, sprocket, drive shaft, differential, axle and wheels. You will see the different components of the drivetrain on your screen. In drivetrain, we use chain drive and open differential. The engine which we use in a vehicle is KTM 390. So we come to the designing part. While designing the drivetrain, we had taken various iterations of at which gear the RPM, what is the RPM that we receive from the engine. By using these iterations, we decided the reduction ratio to find out the maximum acceleration and velocity. So what is reduction ratio? Reduction ratio is nothing but number of teeth of large gear upon number of teeth of small gear. This ratio is called as the reduction ratio. Then we come to the drive shaft. While designing the drive shaft, we had two options, that is hollow shaft and solid shaft. As we had space constants, so the diameter of the shaft was same. When the diameter of the shaft is same, the polar movement of inertia of the solid shaft is more than the hollow shaft. Thus the bending stress of solid shaft is less than hollow. That is why we choose to solid shaft to be used in our drivetrain. Now let's move on to the intake system. As per the rules of the event, we have to use an air restrictor. So for the first 2 years, we used orific plate, which is used to reduce the air intake. But it had some drawbacks, such as pressure difference. So to overcome these drawbacks, we use the Venturi plenum assembly. In this assembly, Venturi does the part of where the air is restricted and plenum is used to recover the pressure losses. The design of the Venturi and plenum is done on the basis of iterations and with the help of a software called CFD, as these are not standard. Now let us come to the third part, that is cooling system. As you know, this is a race car. The engine gets heated up very fast. So to cool it down, we are using a radiator. Radiator is just used for cooling, but the main part is played by the orientation factor, that is where the radiator should be placed, so we can get maximum benefit out of it. Some drawbacks in this that we face are, if we place the radiator on the side, we can experience drag. If we place it at the back, air can't reach there properly. These are the two drawbacks of the placement of radiator. Now, as we saw the transmission system, let us move on to another system that is very important, where every subsystem is going to be fitted, that is the roll cage system. Now, in our vehicle, the main aim and objective of a roll cage is to make it compact and as light as possible and reduce the member as much as possible by satisfying all the rules. We have to satisfy every single rule in the roll cage which is related to the roll cage, and plus keep it as simple as possible. It should also protect the driver from any harm. Roll cage is designed based on rules which are provided by an event which are given in the rule book. You can see the roll cage of our vehicle in the video right on the you can see the roll cage of our vehicle on the screen. There are many different parameters which we have to consider while manufacturing a vehicle, while designing a vehicle. The material which we are going to use, etc., is also have to also be considered. So this was a basic intro of designing process of how we design a vehicle. Now I would like to end this by saying thank you for attending this session.
Thanks, Ashay. That was a good session on designing and Formula Student race car with some designed CAD parts and assembly. That helped to understand the session with ease. Now coming up next is virtuals and fun videos.
की सभी जुबां है, हम हैं हजारों में, अब की कमी जरा है, हर चीज खास है। अब है जो है वो समा है, तुम रह सकी तो रबा है। अब है जो है वो समा है, तुम रह सके ऐसी जीत, अब चाहे जिंदगी ऐसी जीत, अब चाहे जिंदगी है। देखो आने जाने वाले सारे साथ खड़े हैं, कभी ना कभी मैंने भी तो ऐसे वैसे ख्वाब देखे हैं कि हम तो आस पास सांस थमे और रात साथ बात करे, क्यों ना रह लो ना। अब तो आए जा हमको ले जाए जा, अब तो आए जा हमको ले जाए जा, अब तो आए जा हमको ले जाए जा, अब तो आए जा हमको ले जाए जा।
That was a glimpse on virtuals and the fun we had. Now let's have a look at manufacturing that is explained by Prachiti.
Let's take a look at manufacturing. Manufacturing phase consists of the following processes: fiber reinforced plastic process, also known as FRP process, 3D printing process, laser cutting, lathe processes, surface grinding, CNC, VMC, water jet cutting, and dummy. Fiber reinforced plastic process. FRP process is most widely used manufacturing process for production of various components of our car. This process is used to manufacture the following components: body panels, nose of the car, seat, aerodynamic components, transmission components such as plenum, runner, etc. FRP process comprises of four components: fiberglass reinforcements, resins, additives and fillers, and surface finishes. The figure shows us hand layup open molding process. This process is adapted to satisfy certain predetermined objectives. The material used to manufacture certain components should be of low density in order to reduce the weight of a vehicle. It must have adequate strength to bear the aerodynamic forces as well as its own weight. It should be manufactured with ease and should be scratch resistant. The material must be readily available at minimal expense. 3D printing process. It is one of the latest and popular methods used in manufacturing various components of Formula One cars having complex geometry. It is a process which gives the required end product with maximum precision. It is a low-cost method. This method is implemented to manufacture venturi, plenum, etc. Metal 3D printing can also be used to manufacture fuel injector section, brake calipers, wheel hubs, etc. These clips shows us the 3D printing process. This clip shows us the precision with which complex geometry components can be manufactured using 3D printing. Laser cutting. Laser cutting is mainly a thermal process in which a focused laser beam is used to melt material in a localized area. A coaxial gas jet is used to eject the molten material and create a curve. A continuous cut is produced by moving the laser beam or workpiece under CNC control. We use this process to manufacture all suspension mounts, brake mounts, engine mounts, etc. These clips shows us the laser cutting process. Lathe processes. Various basic operations are performed on the lathe machine such as turning, drilling, boring, parting, grooving, etc. All types of sleeves used in a vehicle are manufactured on lathe machine. The first process is the turning process. The second process is the parting or grooving process. The first two clip shows us the dry drilling and drilling process. The boring process is the process of expanding the drilled hole. Surface grinding. It is a process used to produce smooth surface finish on flat surface. The spinning wheel is covered with rough particles which cuts chips, making the work surface smooth or flat. We use this process to give smooth finish to all laser cut parts. The first two clips shows us the apparatus of grinding machine. The third clip shows us the sparks produced during the grinding process. And the fourth clip shows us the chip formation during the grinding process.
Thank you, Prachiti. Some more information on manufacturing by Vaishnavi.
Manufacturing processes consist of following processes: computer numerical control, which is also known as CNC, vertical machining center, which is also known as VMC, dummy, 3D printing, FRP process, laser cutting, motor jet, and cutting tools. Computer numerical control. CNC machining is a process that involves use of computers to control machine tools like lathe mills, grinders. It is commonly used in the manufacturing for machining metal and plastic parts. CNC machine works based on CAD and CAM programs and computer control. CAD, which is known as Computer Aided Design, is a drawing software used to increase productivity of designer, improve quality of design, and to create a database for manufacturing. Whereas CAM, which is known as Computer Aided Manufacturing, having two codes like G code and M code, on which all the programs are written to feed into machine to perform the various operations, that is turning, grooving operations in the lathe. Vertical machining centers (VMC). VMCs are utilized primarily as a metal cutting machines that removes aluminum, steel, and other hard materials. VMCs can be utilized for not only cutting but also drilling, tapping, chamfering, and many other applications, thus shaping a raw block of material into decision form or machined surface. VMCs use components which are rotating spindle, table, tool changer, coolant system, tool covers, chip or screw conveyor, rotating tables, and quick loading loaders. Rotating spindle. The spindle, which is perpendicular to working surface or table, can hold variety of cutting tools. Table. The table is platform to mount the workpieces. Tool changer. A tool changer greatly increases a VMC's productivity by allowing for the computer-controlled selection of tools. Coolant system. Keep the parts and cutters cool and lubricated. Dummy. Dummy is the replica of final object. Dummy roll cage is manufacturing before final roll cage to check the rules. We use mild steel for manufacturing of dummy and chromoly steel AISI 4130 is used for manufacturing of actual roll cage.
Thank you, Vaishnavi. These are the manufacturing processes that we use to build our cars. Now, let's move on to a static session, which will be conducted by Akalpita.
Let's have a look at the static events. Static events are as follows: engineering design, cost and manufacturing, and business plan presentation. Engineering design, which gives the maximum of 150 points, is an event to evaluate students' understanding of engineering process and efforts of designing. The team has to submit the report, which includes the specifications of the designed car. Next up is the cost of manufacturing. When we design a product, the foremost concern we have is about the cost and the manufacturing. This event tests the understanding of the involved manufacturing process and the cost required. The team has to submit the cost report, which includes a bill of material and supporting documents. Next up is the business event. We all know that the product is worthless without the potential buyers. This event evaluates the team ability to deliver a business model in which the product, the race car, could become the potential business opportunity. In the process of product designing, there is a basic brainstorming session, which include data and market analysis, forming a problem statement, working on the probable solution, presenting the product, reaching out on the potential buyers, and market release. Let's all take an example that we work as a product designer at a, let's say, instant noodle company. So we all know that Maggie has been ruling the instant noodle world for a long time now. Looking out at the data and market analysis, its favorism is due to few reasons, which includes its affordability and taste consistency. But one loophole which everyone is tired of is that it gets sticky after a point of. Also, it becomes a really very. It looks like a brick. So the problem statement here is to form or make a noodle which stays non-sticky for a long time. Looking at the probable solution, which may include techniques which leads to the manufacturing of such noodles, presenting the product, reaching out at the potential buyers, and market release follows that. So we have such a noodle in the market which stays non-sticky for a long time, which and also is been a competitor of Maggie for those who don't like sticky noodles. So this brainstorming session requires few skill set, which includes data analysis, which is based on the market, reading the market trends, consumer analysis. It is also important for looking and focusing on the target audience. Next up is the presentation skill. It is basically a way of presenting an idea in a way to attract maximum audience. The interest of the potential buyers is the prime concern here. Also, the body language should be very welcoming, so as to help the potential buyers to point out their interests and necessary corrections. Next is communication skill. We all know that communication has been the basis of exchange of information from a long time. Also, nowadays we enjoy watching stand-up comics because it gives us a funny way of dealing with day-to-day life crisis. Also, living in a country with high communal rights, Zakir Khan still remains our favorite comic, even after religious and communal difference. Him pointing out communal differences after in almost every event still is of the communication skill and effectiveness of his uh, point presentation. Next up is creativity. Creativity is the way of thinking out of box. People always appreciate new ideas and the way to deal with way to deal with a problem statement. Like, and also marketing. Let's talk about marketing. Marketing, we all know the marketing industry is always been in a constant state of evolution. Marketing is just a way of presenting a product to a buyer where they are compelled to buy the products from you. It can be as simple as, let's say, again, Maggie, a packet of Maggie, which is sold with a promise of like getting ready in like 2 minutes. But we all know how much time it takes to make a pack of Maggie. So it's just a marketing strategy to attract more and more buyers. Intuitivity here mainly is best served with business idea and willingness to take risk, whereas curiosity is being helping people to expand horizon and explore new boundaries and increasing their knowledge and area of coverage. That's it from the skill set. Now let's have a look at the technical event inspection videos.
all around clear tape लगा दो so it doesn't fly off.
Next up is the skid pad event. In this event, the cornering speed of the car is measured. The cornering speed is the maximum speed at which the um the car turns at the corner. The racetrack is in the form of the digit 8, and the car is supposed to make 2 full rounds of the racetrack.
Thank you, Akalvita. Maggie was a good example though. Now, with all the experience we had from the last 2 years, we gave all we have to build our third year vehicle, that is named Savita. So let's have a look at its journey. hear some experience from the team captain of Team Abhedya Racers 3.0.
Hello, good evening everyone. My name is Rishikesh Bhosle. I led Team Abhedya Racers 3.0 at Supra S India 2019 and currently pursuing postgraduate diploma in data science. Back in 2016, I was selected as a supporting team member in this team, which was a dream come true because when I was in first year, I used to feel so much fascinated by the passion the Baha team members used to work that too for the day and night in their workshop. In 2016, for the first time, Formula student team was going to form, and I kept no stones unturned to grab this opportunity. Since then, I got engaged in this stuff like designing and building vehicles, and then there was no going back. In 2017, I was elected as the vice captain of the team. On 29 July 2018, the team of 35 members, Team Abhedya Racers, was formed, and I was elected as the captain of the team. So it was my turn to carry the progress and take this team to the whole new level with one goal. I remember the very first meeting we had was held at 8 o'clock in the morning because I feel the hardest thing to sacrifice that we own is our sleep. If we sacrifice our sleep for something, I must say we are very much dedicated to it. As most of the team members were new to this, they had very much potential to build a vehicle. So we made a decision to focus on literature survey to get into the roots of designing, play with the fundamentals and take out innovative designing solutions which was not just better than the competitors but also the best of all. And so we took a long period to implement our innovative designing solutions on the vehicle and given set of within the given set of rules. After going through all the possibilities and innumerous iterations, we simultaneously analyzed the parts and optimized them to its best. While designing, we considered to purchase and install some high-end parts and which had very high cost but mandatory to use to get top-notch performance. And so we approached many companies and decided to run a crowdfunding campaign. I feel so much fortunate and grateful to thank Horizon Shoots, SKF Bearings and Rambering for sponsoring us. And so also to the people who had contributed in the crowdfunding. If you are watching this, thank you so much for your kind help and you will always be the part of team success. With this financial help from companies, colleges, through campaign and our contribution, we finally been able to purchase those parts and build a vehicle. And finally, the day came when the car we built was ready to roll for the first time. And its flawless run made us ensure that the design was initially great. Followed by the driver's practice and getting ready for the statics, we were ready for the competition. On 15 June, Supra SE India was started, on the very first day we cleared the scrutiny, and on the second day we were among the 6 teams that cleared the technical inspection. We crossed our fingers for the dynamics because it was the first time our vehicle was performing skid pad and autocross. But our drivers Amod and Kunal made everyone stunned with their driving skills and dragging the vehicle's performance to its best. And finally, the day came when Team Abhedya Racers representing MMCOE was called upon the podium for the first time. We ended 2019 season by winning runner-ups in Acceleration Award and 14th rank all over India. Also, it was our pleasure to watch our senior faculty advisor Dr. K.R. Patil sir winning his first Dronacharya Award. Being into the position of captain was not easy task. It was like running the organizations, bifurcating my responsibilities. It was like managing human resource, finance and technical all at once. The vision and goal of the team were so dense by will but transparent and clear that each and every team member was dedicated to achieve it. We were actually entrepreneurs, banded together for the sake of competition. And iconically, what defines entrepreneur is his A is very much greater than R. That is, his ambitions are very much greater than the resources he got. In the either way, he creates his resources to reach his ambitions. And that's what we had in ourselves, and that's what we did. While returning back from Buddha International Circuit, I felt very proud and happy but emotional too because it was hard to accept that the journey has come to an end, and the best part of the journey was not the end but it was the journey itself. a journey of the family of 35 members. I remember on Sundays, the team members' parents used to visit us our workshop and used to bring us tasty foods. And they used to feel so proud of their kids by looking that they are practicing engineering right within the four walls along with the several others. And that pride used to motivate us a lot. I miss the 2 hours I miss the 2 hours tea breaks that we used to have, the birthdays we used to celebrate, and the play and that playing football in the early mornings. Well, if I started talking about the fun we had, it would take a very long, and I won't drag it further. Thank you, Mandar and team, for giving me this opportunity, and thank you all for the joining this session. Stay safe and all the best. Thank you.
Thank you, Rishikesh. In 2019, we came up with new team of, for the fourth season of Team Up with the Racers. So let's hear it out from Sakshi.
Greetings to all. Hope you all are staying home and staying safe. Just a little peek into the TAR 4.0 journey. So, it all started with bringing together a group of young engineering students from several branches to see if they could become something more. Every year, a new team of students work together to design, build, and manufacture a Formula Student car. In just a span of months, we went from a blank paper to a brand new, unique race car. The glorious past of three beautifully designed race cars fueled our confidence to make a lighter, faster, and more reliable car. We divide our calendar into 5 phases, beginning with the literature phase. With a combination of innovative ideas, clear vision, imagination, and detailed plan of action, the literature phase faded away to make way for the design phase. In the design phase, every department had to design the part according to the concept they finalized. The team worked hard to transform the creativity of the literature phase to reality. After the design phase is done, the car is assembled on a single laptop. After the assembly, we shifted to the manufacturing phase. In this period, everybody had their own task where they had to manufacture certain parts and bring it to the workshop and assemble it and check if every size and dimension is correct. Material is bought and manufacturers that can fulfill our requirement are sought after. This phase taught us things about methods such as CNC machining, laser cutting, water jet machining, and much more. Team members worked under deadlines to assemble the parts with interdepartmental coordination. Then we made our way to the most crucial and important phase, that is the testing phase. We have to extensively test our car after the manufacturing phase is over, but unfortunately, on the day of our first testing of the newly made race car of the AR 4.0, the college and the workshop were closed down due to the pandemic. Very disheartening moment truly, but nevertheless it just made the team members to strive harder for our next target, that is Formula Bharat 2021, at which we are ready to compete. Thank you.
Thank you, Sakshi. We all know that this COVID-19 situation has hit us hard, but surely we will tackle this situation. With a thought, the shortest cut to success is to work hard, is to be sincere. The way to get sincere is to inject dedication, determination, and discipline. With this thought in our mind, we started with the all new season of Team Up with the Racers 5.0, hoping for the best. Thank you everyone for attending this session. That's it for the day.